having some fun in my kitchen today with the lab soap boat. What you're going to notice today in this lab is that unbalanced forces cause acceleration and that energy may be converted from one form to another. We're using some common items that you find in a kitchen: water from the tap and dish soap. Water, as you may know, is a very sticky substance. Think about when you get your hair wet in a swimming pool, how your hair will stick to your skin until it dries. That's adhesion. Water molecules also have the ability to stick to each other. That's cohesion. These cohesive forces happen because of hydrogen bonding between the water molecules. Hydrogen bonds happen because oxygen will hold on to electrons in the water molecule a little bit more tightly than the hydrogen atoms do. This means that the oxygen side of the water molecule gets a slight negative charge to it, and the hydrogen end of the molecule gets a slight positive charge to it. Those opposite charges are then going to be attracted to the opposite charges of the water molecules next to them. And those places where the negative side of one water molecule gets attracted to the positive side of the neighboring water molecule are called hydrogen bonds. I wanted to show you how cohesive forces can easily hold up a paperclip on the surface of a glass of water. So when we take a look over here at this glass of water, I have to tell you there is a little secret to getting a paperclip to float on top of the water. I should be careful with my wording. Not really floating, resting on top of the hydrogen bonds of the water molecules. I'm going to put a little piece of Kleenex on top of the water. The Kleenex drops away, and there you have it. My metal paperclip is resting on top of those hydrogen bonds of the water. Dish soap, or any soap, can break those hydrogen bonds. I'm going to take a toothpick and dip a little bit of soap onto my toothpick and touch it next to the paperclip, and let's just see what happens. First of all, you notice I can make the paperclip move. And what's happening on a microscopic level is that between the water molecules, you've got forces holding them. Those forces act like stretchy rubber bands. If hydrogen bonds break between water molecules, and one water molecule is no longer bonded to its neighbor, that changes the position of the water molecules relative to each other. So the water molecules begin to move, and as you can see, it eventually makes my paperclip drop to the bottom of the glass of water. So, time to have some fun with boats. I will be straight up with you. I made one boat and I tested it. It does float in the water. I made it just out of a small piece of aluminum foil. And my modification that I made to just a standard boat is I put a little spot in here where I could add some soap to it later to see if I can propel my boat around. Obviously, if I see acceleration in my boat, I'm going to be observing unbalanced forces. And then I, honest to goodness, have no idea what this piece of plastic is from, some kind of packaging. I just found it laying in the basement. But I did notice that it floats. So just to demonstrate that both of my boats float, I'm going to put this one here and this one here. Ta-da! My boats float. Now, the next part, which is the fun part, is I'm going to add soap to the edges of, first, I think I'll start with my circular boat and see if I can make my boat move across the container of water. Here we go. I'm going to dip a little bit of soap onto the side of my boat. And I'm going to put it into my container of water. Let's see what happens when I put the soapy boat into the container of water. Well, check that out. That was kind of fun. Try it again over here. Notice that the second time I put the boat back into the water, I didn't see a heck of a lot of motion at first. And that's because once the soap has broken the hydrogen bonds between the water molecules that are near the boat, I don't get cohesion again. So if I don't have the water molecules moving away from each other, I'm not going to get the boat to move. But I'm now going to swap out to my clean tub of water that I've got over here, and I'm going to try this again with my aluminum foil boat that I made. First of all, I guess I should let this container of water settle down a little bit because I just nudged it. I'm going to put my boat on here. Other than the motion of the water rocking back and forth, you can see that this boat's relatively still, not really traveling anywhere. Now, I'm curious. I tried to be innovative by putting this ledge back here for the soap. I haven't experimented with this, so I have no idea if this is going to give me good motion or not. It's a concept I'm testing right now, right here. I've added the soap to the ledge. Will anything exciting happen, or will it be a dud? There is only one way to find out. And I think I've got some extra motion there. Notice I did get my boat to spin a little bit. That was another goal that we had, to see if we could make the boat spin, and I did. What happens if I nudge my boat over to a different area of the water? Yeah, I'm still getting a little bit of motion. Well, there you have it, my 2 soap boats. I hope you had as much fun making and testing your soap boats as I did. I think this is why Science at Home can be a really good time. Thank you for watching.